Hey everybody, welcome to the February patron-only build video. I'm Patrick Norton.
I'm Shannon Morse.
If you're watching this, I hope you watch TekThing because
why else are you here?
If you haven't, then thank whoever shared the video with you. TekThing, weekly show, technology, TekThing.com, YouTube.com/TekThing. Words are so much easier with consonants.
Yeah, that's true. So what are we building today?
I have always wanted a Past Labs amp, right? So we went to CES. We're back from CES. It's February. We've been back.
It was fun.
We've even recovered at this point from CES.
Right.
And one of the crazy things I got to do that I only get to do every couple of years is to go listen to the high-end audio stuff.
Oh,
right? Because I got to go over, of course. Because I was there basically forever for like 8 days.
Yeah.
And which was cool because I got to see a lot of the high-end audio gear. Like, oh, these are like the $55,000 speakers. And you know, I'm never paying $55,000 for a pair of speakers, but boy, now I know what an amazing set of speakers sound like. The ELAC speakers I was gushing over.
Oh, those were so pretty.
Those were so pretty. They sounded so good.
Gorgeous.
So one of the things I've been reading about forever since I was in college-ish was a guy named Nelson Pass, started a company called Past Labs, and they make Class A audio amplifiers. I've always wanted a Past Labs amp. I've always wanted to have the chance to like spend hours listening to a Past Labs amp because they're legendary. They're Class A audio. We'll talk about that. Or Class A amps. Talk about that in a second.
Okay, good.
Because that gets it. There's Class A, there's Class B, there's Class AB, there's D, there's Class T, which is actually a marketing name for Class D.
Oh wow!
But I said I'd get into that in a second. And these are amps that cost like thousands and thousands of dollars.
Wow.
Right. I'm never gonna be able to afford that stuff. But what's cool about Nelson Pass is he likes experimenting. He likes playing around with circuit topology. He likes playing around with designs, and he's really big into DIY. So there's a website called DIYaudio that he is an active forum member on. And he is big into a thing called Burning Amp, which is an annual gathering here in the Bay Area for...
Is that like Burning Man?
Well, it's like Burning Man, but for audio geeks.
Oh, that's awesome. Okay.
So you can go and you can listen to the amps they've built, the speakers they've built. And the crew behind Burning Amp wanted to do they started doing like a speaker build where like they would get everybody together for a weekend, and they'd get like 50 people together, and everybody would leave. So would they like teach people how to build amps? Yeah, they started with speakers, and they're like, oh, we want to do an amp.
Okay.
So Mr. Pass said, I can do this, and they came up with the Amp Camp amp, which uses discrete components, which is where this is a partway through build we're doing. Discrete components means instead of everything being on an integrated circuit, you go like, this is a capacitor, this is a transistor. This is one of the 2 MOSFET power transistors, a big honking dude. And this is the heatsink associated with these MOSFET transistors.
That makes sense.
Well, we'll get to, there's a reason why that's so huge. So this is a super simple Class A amp. He was concerned about basically people electrocuting themselves in the process of building a Class A power supply. So it is actually powered by a laptop.
That's just like a regular laptop power.
Yeah, 19 volts, 4.74 amp. So,
wow, okay. That's cool.
So you're less likely to hurt yourself on your first amp build. So Class A is really interesting. So the idea is that you have a waveform, an audio waveform, right? You've got crests and troughs. Okay. And I'm going to do a super simple explanation while we're fitting these resistors in, because it is... gets really dense, really crazy, and way beyond my technical skills to explain really quickly. But the idea is that a Class A amplifier is applying the electricity through the entire 360-degree audio wave.
Oh, wow.
So it's going full throttle, full power, all the time.
That sounds awesome, though.
Yeah, well, the idea is like, it doesn't matter how high or low the volume is, you have full power. And that does really interesting things because it means you have these super fast transients. Yeah. Traditionally, it's associated with a wider sound stage. It's the most accurate. It's also interesting because it basically goes back to tube designs, transistor designs. It's incredibly inefficient.
Oh, really?
Yeah. We're talking about like...
Because of the power?
Because of the power, right? Like, well, when you see Class A amps that are like 100-watt amps, they usually have massive, huge, like I've seen one that was like this big and there were 4 heat sinks, like the 4 walls of the amp were giant heat sinks. So it was like a giant, like imagine a CPU cooler that was like this high.
I assume it gets very hot.
And they get very hot.
Yeah.
So these are like 8-watt amplifiers.
Okay.
And one of Mr. Pass's theories, or one of the ideas, he started past labs, and he started first watt with the idea that if the first watt coming out of the amplifier doesn't sound really, really good, who cares about the next 400 watts, right? So he's doing low power amps, experimenting with designs, and giving people a chance, once he's built this kitchen table run of amplifiers, to build them themselves.
Okay.
So there was Class A. Class B was an attempt to reduce power consumption on amps. They kind of split the positive and negative, the crest and the troughs, and through different output devices. Big energy savings, lots of distortion, sounds like crap, not really used. That begat Class AB, which is what most of today's high-end audio amps are, where they basically run a bias current through the power transistors, the output transistors at all times, 50 to 70% efficient, which doesn't sound like much until you realize Class A amplifiers are like 15 to 30% efficient.
Oh, geez.
Yeah.
Wow.
And then there's Class D amplifiers, which you see Class D amps listed all the time. If you search for amp on Amazon, it'll be like Class D or something.
Yeah.
The D doesn't stand for digital, although some are. That was the letter that came after Class A, Class B, and Class C. Class C amps aren't used in audio, often called a switching amp. Basically, they turn off parts very, very quickly. It saves energy, so they're like 90% plus efficient.
Wow.
There are lots of Class D amps out there. For example, the Class T amps from like this company came up with the idea of a Class T amp, which was their integrated circuit amplifier.
Oh.
It's well, Class T amps are actually just a marketing name for a Class D amp from a particular company, which eventually got bought, like everything else, by TI. Some Class D amps sound great. A lot of them sound like crap.
Okay, yeah, I was wondering about that.
And in any case, the amp camp kit, right, which has this, the complete, it comes with everything, because you have the complete enclosure.
Right.
Right, so I have an enclosure, a power supply, and enclosure. All of the parts, I'm going to be really careful not to smash. I mean, MOSFET power transistors, like, look at that. It's all heatsink.
Wow. That's really cool.
So everything you need in the box, but a soldering iron and some solder and a multi-tester are in there.
Okay.
So this is what the PCB looks like. You've seen us show off PCBs before.
Yes.
And it's really, really simple. If you've never built a project like this, you might want to start with something a little bit smaller. A classic thing would be a Chumoy headphone amplifier, but the whole process is really simple. Let me grab a power resistor here, or a resistor. I was very careful. These are, Shannon was very upset because she looked at the resistors, she's like, the values are printed on them, not the codes, right? Because usually resistors have these.
I'm so used to the color codes on them, because you always find the color codes, and there's always a nice little graph. But these don't have that; they just have them written on there, which I guess is nice, so you don't have to figure out the conversion yourself.
You might need a microglass. I'm inventing words today. Today is word inventing day for me. But for example, so this is like 68.1 kilo ohm. This is like R12. No, yeah, R12. There it is. No, this is R3. Math is hard, 0.68 ohms.
Okay.
So, when you're doing this, you take your part, you bend it over very gently, very calmly. I like to do it so that the actual value of the part is listed at the top for a resistor. So if you had a magnifying glass, you could see it said 0.68 ohms here.
We got B-roll.
We got B-roll, but it's nice to remind people. You just slide it in there and seat it all the way in. Apparently I didn't twist it tight enough on this one. It'd be great if I broke the resistor, which is almost impossible to do. And then you do that 15 more times and start soldering. What's one of the really nice things about the Amp Camp amp and a lot of the DIY audio projects is people have gone through and done photo by photo, step by step build guides.
That's so nice.
Which are really awesome. Like the TLDR version is first you do the small resistors, then you do the big resistors, then you do the variable resistor, which I of course forgot to do until after I did the capacitors. We like to remind people here on TekThing that capacitors are polar. There's a positive and a negative.
Huge capacitors.
These are huge capacitors because this is a power amp. The longer of the two leads off the capacitor is the positive.
Yes.
And they also do a really good job. That's negative. the big long, negative
the long
sign
line is negative.
Is negative. It's just they go at it. The entire electronics industry is trying to help you keep from screwing this up.
That's good.
you know, there's basically lots of bending and soldering, and then you get to the point where we're going to work on the transistors. I was doing a lot of this alone because
I was busy.
We've both done a lot of soldering, and there's really only so much time in your life you can spend someone else just watching someone solder.
Yeah, that's very true.
So what I have here, and again, this is a situation where polarity matters, is I'm going to read my guide here. Q1, Q2, Q3, which is a ZTX 450, which is one of the two of these smaller transistors. So these were mounting high because that's the way they did it in the two different build threads I read, and that also helps isolate the heat from the soldering iron from the transistor. And they set everything up really, really nicely. It's a beautiful board layout, right? Both the capacitors, the negative side is facing the same, all four of the capacitors, the negative leg, the negative side is facing the same direction towards the top of the board. The backs of the transistors are all facing, like right there, inserted it is all facing towards the largest transistor on the board. And this part always makes me nervous, but you gotta bend the legs out a little bit. And once we do that, okay, Q3, ZTX 450, you can just about see that if you're really lucky. The flat side go towards the big capacitor. And if we start sweating, it's not because we're that nervous, it's because we're in this crazy midwinter heat wave here in the Bay Area.
Yeah.
So if where you're at,
it's hot.
If it's like 30 degrees, I'm really sorry, or 15 degrees or 12 degrees, because it's
hot.
It's like 80 degrees here. I'm gonna bend those leads a little bit.
Oh, you're not sticking them all the way through?
No, this is the way they built them.
Oh, okay.
For everything else, I jam the resistors.
I always jam my resistors in as far as they'll go.
Yeah, the resistors and the capacitors are all the way down to the PCB. The people who built these before me put their transistors this way, and since I'm pretty sure they're smarter than I am, I'm going to do it the way they did it. Let me grab a little bit of solder here. All right, so we got our leads through here. Yeah, the capacitors and resistors I left super high on the board, or excuse me, I jammed all the way down to the board. These I'm leaving up higher because the people who did the demo builds did that. Wiring, giant MOSFET, wiring. I think we're in good shape. All right.
Cool.
This is the heatsink.
Boy.
And
wow.
Yeah, it's a little crazy.
It's huge.
So we got to put a couple risers there, and then the MOSFETs go here.
Okay.
So heatsink inside of the amp. We're going to bend these up at a 90-degree angle, right at the part where the leg gets fat.
Okay.
If I was fancy, I could probably just, oh, heater.
Oh, that works.
And one will go here. So in between the transistor and the heatsink, we're going to put these Keratherm insulators.
Ah, yeah.
They're going to go right there to keep us from lighting things on fire.
Okay.
Quick shout out to iFixit. Project Toolkit.
Yes.
Screw all the things.
Gosh, that thing is so useful.
It is. So I could probably use scissors for this, but then I would have to leave the studio. And look at that. It's already pre-cut.
Oh, nice.
I'm just following the lines.
It's useful. And what is that?
This is that Keratherm insulator.
Ah, okay.
So instead of using like mica and a heat conducting paste, we use this fancy bit of technology. So this is the Rca Jack, and one of the things to remember with this, right, there's a bolt that holds it down, there's the tab that goes on the outside bit, and there's a couple of washers. And you notice that one has a shoulder on it.
Yeah.
Yeah.
Why? Why is that there?
That's to keep it from contacting the chassis itself. Oh. So that's basically to insulate it from the chassis. And these are our binding posts. And
oh, yeah.
You've seen these before.
I've seen those before. I see these on amps. Gee, I wonder why.
In this case, we've got 1 bolt, 2 bolts. So we'll do this so everybody can see it. And ta-da, and again, a shoulder that goes inside the hole on the back.
Cool.
Don't forget that.
Okay.
Because if you ground everything to the chassis, you're going to be really sad.
Gotcha.
I'm just saying.
Yeah.
So let me start setting this up.
Okay.
Right now we're going to insert the Rca Jack, the binding posts, and we're going to grab our power connector, and we're going to put those through the back of the chassis except for the power connector, and we're going to start soldering everything together.
Okay, cool.
There will be a frenzy of wire stripping and bolting and such. In the spirit of DIY, I divided the wire in half, put half of it through a little hole, and wrapped the whole mess around the entire thing. Now I'm going to solder the snot out of it. So, you know.
It's a mess, but it's going to work.
Well, that's an interesting surprise.
What's that? Do you have to feed it through? Like, thread it?
No, it's just not big enough. Yep. Huh.
Oh, does it go in the middle?
Nope. Oh. But we're going to check. That's the same size hole. Maybe even smaller. Yep, smaller.
Oh.
So now feeling a little paranoid. Oh, good.
Good thing that works.
Yeah.
I thoroughly enjoy drying all the things. It reminds me of being at home and drying my hair for 45 minutes.
You could embrace your naturally curly hair.
My hair's so curly.
How curly is it?
This curly.
Hey there.
I think this gets hotter than my home hair dryer.
It should. Be careful you don't light yourself on fire.
Yeah, really.
It is always so awkward.
Thing is pretty hot. That would make for great TV, though. Shannon's fire hair caught on fire.
You say that now.
Lols.
What's she gonna do next week? I understand she's gonna burn herself and disfigure her face with acid. Total YouTube moment. I'll just hold this at a distance.
That's a good idea.
Should we do both of them to cover up my monstrosity? Actually, we should leave that in case I have to resolder it again.
Yeah. You might want to cover it up at some point, but
at this point, it's not going to arc because heat shrink.
Yeah, it's fine now. They have no chance of touching each other.
I'll be right back.
Okay.
Because my 10,000 bit set and my super cool round files are at home, we're going to improvise.
Okay. Is it big enough?
Nope.
All right, we're getting there. Aha! It fits.
Yes, it does.
All right. Let's go back in the studio and finish this.
Now it's the time for more soldering.
Okay.
Something I've never been good at is twisting wire togethers.
Oh, yeah.
So people twist wires together, it's so obvious that they can manage to make everything all smooth. And
so where do these two wires go?
these are going to go from the Rca Jack. These are going to go from here The yellow goes on the outside, the purple goes in the center. To a heretofore unspecified location on the motherboard. I'm going to leave these incredibly long and then trim them down later.
It's a good idea. Just in case.
If I was a better human being, my little windings would all be the exact same length.
Yeah. It doesn't matter that much.
No, truthfully, it's a sign that I'm a bad human being and must be stopped. I read about it. Harper's Bazaar did a great article on that. The trick with soldering wires through from the top is to not leave too much lead on there. Okay. So you don't want it
sticking out at the bottom.
Yeah, you don't want to ground it on the heatsink.
Yeah.
Yeah, we're going to put the switch through the front plate.
Cool.
I like the fact that there's like a slot on the switch, or slot in the board and tabs on the switch to make sure you put it the right way up. All right, so now we got to get the switch from the power positive to the switch, and then the switch to the power here. So
okay.
I may need to find some more red wire. It occurs to me I should put this on before the rest of the front plate.
The little LED.
The little LED and its little.
Oh, you got it in there. So does the.
I've scratched the enclosure.
Oh, it'll be fine.
Ruined it.
So, oh, the LED goes through that big hole on the front plate.
Hence the little light up when you turn the front panel on.
Gotcha. Okay. Signifying that it's actually receiving power. That's awesome.
If I was a really hoopy fruit, I would have put like blue electrician's tape over everything that I could possibly scratch. I'm not that hoopy a fruit yet, but I know where my towel is.
Hoopy fruit? I've never heard that saying before.
Have you never read So Long and Thanks for All the Fish?
Who's it by? Somebody? I'll Google it.
Oh my goodness. This is awesome. I had no idea you'd never read that. This is so awesome!
By the time this episode airs, I will have Googled that.
Yeah. The Hitchhiker's Guide to the Galaxy, Life, the Universe, and Everything.
Oh, I've read that.
Yeah. Hoopy Fruit knows where his towel is at all times, or her.
Oh, that's where that saying comes from. Okay.
I was like, there's no way you haven't read The Hitchhiker's Guide to the Galaxy.
Yeah, I read it like 15 years ago.
Okay. Again with the... Hey, I think it might actually work, kids.
Cool. Okay.
So, but before I get all cocky about that.
Yeah, before you screw everything in, you gotta get the LED wired up.
Yeah. Purple to positive.
And y'all remember how to do your LEDs positive and negative from the last build video.
The longer leg is positive?
And look for the flat side of the LED.
Can't see it no more.
Oh.
Well,
That's
you know, it's buried.
You can use the length. Length of the wires.
Positive, negative.
Gotta steal a little bit more of Darren's.
I don't think he'll mind.
I don't think he'll know.
Uh-oh, we're stealing Darren's heat shrink.
Darren has a very generous policy with his heat shrink.
Well, he has so much of it.
Yeah. Or he did until that afternoon when he saw how much they'd used.
Would it be really mean of me to just like...
Yes. I had it sitting in the back of my car in the car one day, and the sun like refracted through the window, and I went to use my heat shrink, and the entire box had a band of sunlight hit it, so it was all shrunk down the middle.
Oh.
I was like, wait a minute.
That's funny.
What happened here? My heat shrink. Yeah, I was like, what the? And then I realized, I went back to the car and I looked where it had been sitting, and the band of sunlight was still sitting there. And I was like, gosh, fiddlesticks. And yes, I actually did say fiddlesticks, because...
Pass ACA Class A Amplifier. Mwah. Meow. Dun, 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 dun,
Dun, dun, dun, dun, dun, dun, dun, dun, dun. What do we say? Long leg is positive?
I think so.
You think so?
Yeah.
You think
I'm
so?
pretty sure that's right. You want me to Google it real quick?
Nah, let's go for it.
Okay. Nice.
All right.
Wow.
It's crazy pants. So now I'm going to screw the bottom half of the case together, the enclosure, and put the feet on, and then I have to kind of flip it over, and we have to set the bias, which basically means setting the voltage. And we want to have very close to 10 volts. And so what we do is we're going to fire it up, and hopefully the magic smoke does not come out. And if the magic smoke does not come out, we wait about a half an hour and we reset the voltage to 10 volts.
Okay.
And that's why we have our friend, the voltometer here.
Yay!
And then once that's done, I get to build the second one, and I can listen in stereo.
Awesome.
Yes, not that there's anything wrong with mono, it's just not my thing. I was raised on stereo. Although at one point in my life I did have a couple of really cool 78s that were mono. Les Paul, Mary Ford, good stuff. 78s, very fragile.
Oh, I'm sure.
That's why, one of the many reasons I love CDs so much.
Mm-hmm.
It's very hard to kill.
That's very true.
Look, giant feet.
Oh, those feet are so cute.
Okay, you guys want to see if the magic smoke comes out?
Yeah, let's find out if it works.
You're all casual about that. See if it works.
Let's see if it works.
I'm going to leave the lid off. All my resistors were sorted. No, they're not. We'll leave the lid off.
Probably got it on video, so we'll figure it out.
Oh, it's okay. I can read them again. Are you ready?
I feel like I should back up just in case it explodes.
I can go get my safety goggles out of the out of the garage.
Okay. No, I'm good. I'm good.
Do 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 do. Although if magic smoke comes out, I'm gonna be really sad.
I will too. It's getting late.
Oh, nothing worse than a failed build. Except for maybe 2 failed builds. Or 3 failed builds.
Well, we've already had one this month, so.
It's not failed, it's just not done yet.
Yeah.
You'll finish it. I have faith in you.
Ready?
Ready?
I'm ready.
Ah!
Don't do that. Oh my gosh.
It's a tradition Michael and I started. Is the LED on?
Yes.
Woo!
The LED is on.
Did I put the power switch on upside down?
I don't know. No. Well, I don't know. Maybe. That is straight. So you are closing the circuit.
All right.
Woohoo! It works.
We'll be back in just 30 minutes. So the last thing you do on the amplifier is let it heat up for half an hour, right? So I'll show you where it was. The whole thing was assembled to sort of give us our realistic heat drain.
Yeah.
And then you pop the side panel off.
Okay.
And you might want to grab the GoPro, because what we have to do is adjust the bias using this little doohickey here, potentiometer. So the final thing you have to do is you have the amp assembled and running, and you feel this. Feel it?
Whoa.
Yeah. Remember what I said? It's running at 100% all the time.
Yeah.
So those two power MOSFETs in
That's
there
hot.
are, she means in the temperature sense.
Ooh. Sorry guys,
generating
that was loud.
a fair amount of heat.
They are.
Let's double check that heatsink down there. But what we need to do is adjust the bias, and we do that using this little potentiometer right here.
Oh,
and I've been
that's what
fiddling
that's
with
for.
it.
Okay.
So we ground and the center pin on Q1, and take a look at our multimeter. Oh!
10.05.
I'm taking that.
Okay, cool.
Because adjusting this clockwise, basically adjusting this clockwise turns the voltage up. Adjusting it counterclockwise takes the voltage down.
Gotcha.
And a little bit of movement goes a long way, and it'll take a minute or two to settle down. So just for fun. So that's like 10.04.
Cool.
And I'll double check this after I let it run for a few more minutes.
Okay.
But as scintillating as that might be for everyone at home, I'm going to deny you the opportunity of sitting around and watching an amp not do anything.
Thank you.
Don't get me wrong. And now all I got to do is build the second one.
Sweet. Okay, so this one is done. All you have to do is screw on the side plate.
Yeah.
Or the top plate. Yeah.
It
works.
Yeah.
That's great. I am so happy to see that it runs.
I
That's
can't wait to plug it
awesome.
into speakers and see what it sounds like.
Yeah, me too.
It also occurs to me that this goes like this. Which makes me wonder, oh, there we go.
Oh.
Now the screws line up.
So I think we should talk about this once it's built on our normal episode every week.
Every week?
We will talk about it every single week.
Every single week. Forever. We have a goal of 1,000 shows.
But once you have them both built, you can chat about, how the sound quality is and everything.
I'm very excited.
Me
I'm
too.
Also kinda it's been a while since I've built a project that
Oh,
involved
yay!
soldering and heat. And didn't involve working on the house. So
Yeah.
I'm also kind of tripping at how much heat's coming off this heatsink already.
It's getting a lot.
In case you didn't see it before.
Yeah, that's a huge heat sink.
It's a big heatsink.
There you go. Yeah, you can see it. That is big.
Like a third of this is
Wow.
heatsink. Oh, there we go. Now you can see it.
It looks good though.
It's exciting.
Nice and clean. The LED is working just fine, letting you know that it's on. Great job.
Thank you. Thank you
Excellent job.
Now let's go see what it sounds like.
Okay, cool.
Yay. And then I'll let the music. All right, folks, ladies and gentlemen. We'll see you next month.
We will. Thank you so much for watching and supporting us on the patreons.com/TekThing. That was the worst read ever.
No, but it was down there.
Patreon.com/TekThing. Share it with your friends and family if you want them to watch build videos as well. They are just for you guys because we appreciate you.
And, if you don't want to share the build video, fix their computers.
There you go. I'm gonna go home and eat some dinner. So I will catch up with you guys next time. Bye!